Hello, my name is Dr. Courtney Siegert. I am an assistant professor in the Department of Forestry of Forest Hydrology and Soils, and today I'm going to be talking about preparing for the future weather and climate trends in Mississippi. So to begin my talk, I just want to discuss the differences between climate change and climate variability to frame where we will be going with this presentation and how it fits into your daily management decisions of forest in Mississippi. So climate variability is really the interannual and very short year-to-year variability that we see in climate systems. And that variability can come from temperature changes, precipitation changes, and on this graph you can see that the annual up and down of the red line represents that variability. So in one year it can be very warm, in another year it can be very cold, and the same thing goes for raininess. So one year it can be very rainy, and in other years it can be much drier. When we look at these trends over a much longer time scale, that's when we look for positive or negative trends that give us an indication whether climate change is happening. And so for management decisions, year-to-year and inter-year variability is much more important for landowners and forest managers than long-term decadal changes in climate. And so this talk is really going to focus on the year-to-year variability, how we can understand that variability and make better management decisions, and where we can find sources of information to help us guide those management decisions. So as I begin this talk, I want you to think about ways that climate variability may have affected you, the land that you manage, or the land that you own. Specifically, if you've ever been impacted by negatively impacted by climate variability. So examples of this could be if you've had a tornado go through your property, or if you've had a hailstorm come through your property and damage some trees, or even if you've had to postpone management decisions and actions like harvesting or burning because climate conditions were unfavorable when you thought they may have been favorable. So all of those represent ways that climate variability can negatively impact our land management and decisions. Also think about how your forests and lands may be impacted by climate variability in the future. So all of the ways that climate variability impacts our land currently will continue to impact it in the future, and we also expect that these impacts will be more significant and more frequent. And so think about how that may affect you and your decisions. And then lastly, think about how you can make decisions that will help you better adapt to current and future climate variability. So I want to begin here looking at the significant climate anomalies and events in 2016 from the last year. And so these are significant events that happen globally throughout the world. You can see that every continent across the world has been affected by these anomalous events. Many of them are related to high temperatures, but others are related to other climate variability events like hurricanes and Arctic and Antarctic sea ice melting. So this is a global phenomenon that's not just local to the United States and the southeastern United States. A lot of this variability and these anomalous events are driven by changes in surface temperatures. And so here, this map is showing you globally where for the last year in 2016, where temperatures were above average for from the record of 150 years, and where they were below average. So the pink and the red colors are above average, and you can see that all of the continents, the land surfaces, have grid squares that are above average, and those ones in the darkest red are the record warmest. So every single one of those squares that is the dark red, those are areas that experience record warm temperatures for 2016. So warmer temperatures than any time in the recorded history. There are a couple of blue colors up there. The largest of interest is probably around Greenland, and that is probably driven by melting of the Greenland ice sheet, which is inputting a lot of cold fresh water into the North Atlantic. So it's not necessarily that the atmosphere was colder, but that the result of a warmer atmosphere was leading to colder surface temperatures through melting. But this trend is common across the world, and the grid cells with record warmest temperatures are really starting to increase in our current record. If we focus on the United States for 2016, the selected significant climate anomalies and events, we see a lot more variability in the types of these events. And so some of them are driven by temperature and some of them are driven by precipitation, although in the long run, temperature and precipitation are interacting to produce these events. So some of the events were caused by very heavy inland flooding in Louisiana, Texas, and West Virginia throughout the year. There were 4 separate very heavy rainfall events that caused that flooding, and these were all inland rainfall events, so not flooding events that were caused by a hurricane, as we are used to seeing. Also, in the southeastern United States, we experienced a significant drought this fall, and that resulted in very dry conditions. And in fact, there were regions of the southeastern United States that did not get any precipitation for more than 50 days. The drought out west in California was eased a little bit by rainfall that was primarily associated with a very strong El Nino year, which I will talk about as we get farther into this presentation. But so you can look and see that throughout the United States, there are significant climate anomalies and events caused by climate variability, and they range from very hot and dry conditions to very wet conditions, and so it depends on where you are. Many of these are related to climatic patterns, and we are able to predict them to some degree, and being able to predict these can definitely help in management decisions. So scientists unanimously agree that climate change is happening and that it's man-made. And so a survey of the peer-reviewed literature where the majority of science is published, a review of this from 2011 to 2013 showed that 99.999% of climate scientists agree that warming is occurring and that other changes in climate as a result of man-made emissions are contributing to these changes. However, an on-the-ground survey of foresters who live and work in the Southeast indicated that only 10% of those thought that man-made global warming was occurring. And so we have a disconnect between what scientists are observing and reporting and what people who live in the region and on the ground are actually reporting. One of the reasons for this is that in the last 2 decades, there has not been as much warming in the southeastern United States as there has been throughout the rest of the country. And so on this map, you can see that the warm colors are positive changes in temperature. So temperatures are generally getting warmer. And this is for the time period 1991 to 2012 compared to about mid-century average temperatures. And the blue colors, which are mostly concentrated around the southeastern United States, represent cooling or neutral changes in temperature or no change in temperature. And so it's possible that people living in the Southeast are not experiencing the same level of temperature changes as those throughout the rest of the country, and that can lead to bias that makes us believe that global change is not occurring. However, just because it hasn't occurred regionally in the past 2 decades does not mean that we don't expect to see those influences happening. And in fact, these data go through 2012, and more current data are showing that the Southeast is catching up to the warming throughout the rest of the country. So it's not just temperature that is important for global change and that's driving global change, but there's other climate factors too. Some sources of information include the U.S. Drought Monitor. So the U.S. Drought Monitor is published by the USDA along with NOAA, the National Oceanic and Atmospheric Administration, and they publish weekly maps of drought conditions across the United States. And these maps are very important for informing people about the current conditions and the persistence of these current conditions. So on these maps, the very dark red colors indicate much stronger or more severe and extreme drought conditions. There's also letters on these maps here that show A and H. And so moving forward, as we get closer to present day, these letters have changed to S and L. And so A, which here is represented by agricultural drought, is now considered S, or a short-term drought. And what this means is that it's probably less than 6 months that we have been in rainfall deficits, and that will certainly begin to impact crops which are shallow-rooted, and crops may require irrigation, but for natural systems, it's not as impactful. H, or what is now referred to as L, for long-term drought, is a much longer duration drought. So there have been rainfall deficits for more than 6 months, and we're beginning to see hydrologic impacts on natural ecosystems. So lake levels and man-made reservoirs are beginning to decline, as well as natural ecosystems are beginning to be impacted. So under short-term droughts, forests with their deep-rooted systems can usually withstand a couple months of under-average rainfall conditions. But if those conditions persist for 6 months to a year to longer, then forests tend to be more impacted. And so the U.S. Drought Monitor can provide you information about what the soil moisture and water resource availability is in your region. Beginning in August 2011, we're going to look at August conditions over the last 5 or 6 years. You can see that there was some drought in Georgia and throughout much of Texas. Jumping to 2012, the Georgia drought deteriorates and becomes worse, and the rest of the drought in Texas starts to move northward. By 2013, the drought has been resolved in Georgia, and drought conditions begin to move even farther westward. And by 2014, that severe California drought that we've heard about in the news begins to set up and deteriorate in those conditions. By 2015, again, you see some short sporadic droughts in the southeast. And then by 2016, the southeastern droughts and the northeastern droughts become significant, and the droughts on the west coast become slightly abated because of the excess moisture from all of the rain from El Nino conditions. Now, what is anomalous here is at the end of November, we actually see worse drought conditions in 2016 than we saw in August. And so the lack of rainfall throughout much of the southeast and also throughout much of the northeast led to these very anomalous rainfall conditions that can impact a lot of our forest activity. And so during this time period, this is typically the natural fire season. And as we know from a lot of the news reports, there were some very dramatic fires throughout the region that were difficult to control and contain. This is not the time period when a landowner would be burning with prescribed fire, but it is important to note that natural fires were much more of a threat this fall than they had been in previous falls because of these anomalous conditions. And so because the droughts became so severe in the fall of 2016, it's going to take a lot of rainfall to bring us out of these droughts, especially in the southeast. And so that means that even moving into the spring, as some of the droughts have been abated, it's going to take several months of above average to average rainfall to relieve these conditions. So even prescribed fire activities in the early spring, when they are typically performed, may be problematic in the area because we're still recovering from this drought. But we'll have to wait and see how much rainfall we actually get this winter. And then this slide shows where we are currently as of the middle of January 2017. So we have had rain and it's helped with the drought, but again, we are still in significant drought conditions that need to be considered when you're planning some of your management activities, especially burning. So we can have not enough precipitation, but we can also have too much precipitation. And so this is the statewide precipitation ranks for 2016. The blue colors represent more precipitation than average, and the brown colors represent less precipitation than average. And this is comparing the records for each state over the 122-year record history. So the numbers within the states are actually telling us how wet or how dry the year was. And so, for example, in Minnesota and Wisconsin, those states were the If the record wettest year was 122, this was the second wettest year on record at 121. In Alabama and Georgia, it was the 11th and the 9th driest year on record in those states. And in Connecticut, it was the 4th driest year on record. So we can have parts of the country that have very wet years, and we can have others that have very dry years. And it impacts our management decisions across the country. However, in a given year, we have those trends over a longer term. So this is the last 2 decades compared to the first half of the 20th century. The changes in precipitation are much more sporadic and much more difficult to predict than changes in temperature. And so you notice on this figure that there are regions that have increased in precipitation immediately next to regions that have decreased in precipitation. And so the consistency of these changes across the United States is much more complicated than the consistency and changes of temperature. And that's something that we have to be aware of going forward, that precipitation and rainfall is much more variable than temperature changes. And so that can make our management decisions more complicated. How we get this rainfall is also changing. And so in the last 60 years, we see an increase in heavy precipitation events. And so these are heavier than the 1% of the heaviest rainfall events. So what this means is that the intensity of rainfall is increasing. In the southeast, it's increased by 27%. In the northeast, it's increased by a whopping 71%. And this is important for forest growth because when we have very heavy precipitation events, the soil can only hold so much moisture. And as a result, any of that excess moisture is diverted to runoff and runs off into streams and rivers and eventually flows to the ocean. If we have lighter rainfall events, then that allows soils much more time to absorb the moisture and store that moisture for dry periods when trees need it. So by increasing the rainfall intensity, even though we're getting more rainfall overall, we can end up seeing less storage in soils for our forest ecosystems because that too much rainfall is happening at once and most of it is being converted into runoff. So the take-home point of this is that we don't necessarily need warming to have major disasters or to have climate activities that influence our forests negatively. And so in 2016, there were 15 $1 billion or more weather and climate disasters. This is a record. This is the second highest number of climate disasters since 1980, with 16 disasters happening in 2014. And so you can see that many of these billion-dollar weather disasters are associated with rainfall. We have the flooding that occurred in Texas and Louisiana on 3 different occasions, in addition to the flooding that occurred in West Virginia. These are inland floods again, and they're not caused by hurricanes, just very massive storm systems that sat over the area and dumped a lot of rainfall over a very long period of time. What's important about these is that in the past, the record number of inland flooding events had been 2, and this year we had 4. So we're seeing increases in intensity and duration of rainfall events that lead to flooding that can impact many of the forests and the natural systems in the area. We also saw dramatic wildfires across the southeastern United States, most notably those that were in and around the Great Smokies National Forest in Gatlinburg and Pigeon Forge. Even though the drought in California began to ease with excess precipitation from El Nino, there was still significant damage to crops in that region. And then we had other severe weather and tornadic outbreaks, along with the first Atlantic hurricane to hit a coastline since 2007, which was Hurricane Matthew. And so all of these disasters are caused by climate variability, and in the long term we can say that most of them are a result of climate change, although we can't specifically say that one individual event is caused by climate change, but they all exhibit those trends in increased climate variability and severity that we would expect to see. So even though warming temperatures are not impacting the Southeast as much as other regions, climate variability is. And in fact, the Southeast region leads the nation in billion-dollar weather disasters because we are subject to hurricanes and tornadoes and ice storms and flooding and many other types of disasters. And so this means that our forests, the forestry industry, is very susceptible to climate variability, but we can take steps to make sure that we try to mitigate our disasters and our losses in these instances. So we can think about predictable variability. Certainly there is year-to-year variability in rainfall and temperature, but some of it is predictable, and we can use sources provided by the federal government to make good management decisions using our knowledge of predictable variability. So the main one that I want to focus on, because it's been in the news for the past 2 years, is El Nino. And so beginning in winter of 2015, we started to see the impacts of very strong El Nino throughout the world, in the West Coast and globally as well. And so here are just a couple of headlines of El Nino impacting the West Coast all the way down to flooding along the Mississippi River in Mississippi and Louisiana. And so El Nino is really changes in sea surface temperatures in the Eastern Pacific Ocean that impact large-scale atmospheric circulation. So on the map on the upper left, you can see the North American continent in the black outline, and then all of those colors are the differences in sea surface temperatures. And so in El Nino conditions, in the top globe map, you see those very bright white colors along the eastern equatorial Pacific Ocean. And that's signifying that we have warmer conditions in the sea surface temperatures than normal. And because this is occurring over such a large portion of the ocean and a large percentage of the Earth, it greatly impacts our atmospheric circulation. So El Nino is when those water temperatures become very, very warm. And La Nina is the opposite phase. So when we see unusually cooler waters in the Eastern Pacific Ocean, and in that bottom map, you can see that the colors have now turned purple to blue. And so because these have such strong impacts on global circulation, they help us understand seasonal weather outlooks and seasonal weather forecasts because they are relatively predictable. And they give us a pretty good idea of what's going to happen. So during a typical El Nino winter, the jet stream, which is that very strong movement of wind from west to east across the continental United States, splits in two, so that the lower jet stream is dominant over the southern United States, and it brings cooler or warmer and wetter conditions, whereas the northern portion of the jet stream pops all the way up into Canada, and it helps block some of that cold air coming in so that we typically have drier and milder conditions. In La Nina, the jet stream is pushed farther northward, and much of the entire southern United States from coast to coast is milder and drier, and the Pacific Northwest becomes wetter than normal. And so these are typical conditions that we would expect to see in El Nino or La Nina phases. And that really helps guide seasonal weather forecasts, which you can use to your advantage for management decisions. So currently, we are transitioning into a La Nina phase. This figure goes back to 1950, showing the fluctuation between El Nino and La Nina years, with El Nino in the positive reds and La Nina in the negative blues. And so you can see that there's some cyclical variation. So we typically move from El Ninos to La Ninas and back and forth. But the duration of these events is not set in stone. They can last for 1 year, they can last for 5 years, as the El Nino conditions in the 1990s did. And then a strong El Nino does not necessarily predict that there will be a strong La Nina following it. But we monitor the sea surface temperatures, and the National Oceanic and Atmospheric Administration releases these changes weekly. And so we have ideas of where the conditions are going and how that will impact our climate in the United States. What this means is that for precipitation during El Nino events, the southern United States is typically wetter, and during La Nina events, the southern United States is typically drier, and it's much drier during La Nina than it is wet during El Nino. And so as we transition into a La Nina phase right now in the beginning of 2017, we are noticing that it is warmer than usual, especially with the fall 2016 that just preceded us. And so knowing this and knowing that La Nina can persist for several months, if not years, we can begin to anticipate some of the impacts that this may cause on our management decisions. So for those of you who may be interested in harvesting this winter, a lack of precipitation can be beneficial to your management activities. For those of you who are interested in burning this winter, it may be too dry on specific days when you may want to do that. And now this doesn't mean that if we're in a La Nina situation, that we won't have a wet spell for a week or two, or if we're in an El Nino situation, that it won't be dry for a couple of weeks. Certainly you can experience weekly or daily wetness that is uncharacteristic of that. But in the long term, for those winter conditions, this is what we would expect to see. And for temperature during El Nino conditions, the southern United States becomes a little bit cooler, and during La Nina conditions, it becomes a little bit warmer. Again, that can influence harvesting as well as burning or planting activities. And so knowing which phase we're in can be very important for planning a month or two out in advance. So some other sources of information beyond the Drought Monitor and finding out about the El Nino Index, we can look at seasonal outlooks that the National Oceanic and Atmospheric Administration releases. And so on the website climate.gov, we can look at seasonal outlooks for temperature and precipitation. Here we're looking at the precipitation outlook for winter 2016-2017. And you can see in the southern United States, there is a probability that it will be drier than normal. The more coastal you get, the higher that probability is. And then in the northern United States, there's a probability that it will be wetter than normal. Where it's white, there are equal chances of it being wet or dry, so you'll probably experience average conditions. And so this jives pretty well with what we would expect to see during a La Nina year. So La Nina is really driving this forecast. But again, there are other circulation patterns and there are other localized atmospheric conditions that can impact these patterns for a couple days or a week, but generally we would expect to see this coming year. So if you want to get in and plant or harvest, this may be an optimal time to do it this winter. But burning, we may have to take caution and think about what the potential repercussions of burning may be this season. Here is the temperature seasonal outlook for December through February. Again, and you can see most of the southern half of the United States is predicted to have warmer than average temperatures, while a very small portion of the north central United States is expected to have colder than average temperatures. And so warmer temperatures, most of us like those in the wintertime, and it makes outdoor activities a lot nicer. But with warmer temperatures and less precipitation, that can impact drought impacts in many places. So we'll have to keep an eye on that too. NOAA also issues monthly outlooks. And so these monthly outlooks tend to be a little bit more certain than the seasonal outlooks, the same way that 3-day weather forecasts are more accurate than 10-day weather forecasts. So the farther out in time you go, the less accurate our forecasts get. But these monthly and seasonal forecasts are not specific with the days that it's going to rain, just the general conditions. And so here I pulled the monthly outlook for December of 2016 that we just experienced. And you can see that a large portion of the southern United States and the western United States was predicted to be warmer than average. And in fact, in Starkville, Mississippi, at Mississippi State University, our average December temperature was 58 degrees, while the historical average was 53 degrees. So we were slightly above normal in that time period. So the monthly outlook did a pretty good job on getting the temperature there. For precipitation, the southeastern United States was predicted to have lower than average precipitation in the month of December. We had 0.9 inches, and on average, we typically get 5.65 inches in December. So this forecast definitely got the direction of precipitation correct, but it certainly did not capture the incredible dryness that we experienced in the region. But it still gave us an idea that it would be dry, and in fact, it was very dry. The National Interagency Coordination Center releases wildfire potential outlooks, just like NOAA releases weather and temperature outlooks. And so they take into account precipitation and temperature, but also fuel conditions throughout the region. And so they issue monthly outlooks, and then they issue later seasonal outlooks. So here I pulled the one for March and April of 2017, and you can see that a large portion of Florida is under increased fire potential activity, whereas the rest of the country isn't. And so you can use this resource to also guide decisions, especially if you're interested in burning. Other sources of information, you can visit the Mississippi State University Extension Center at msucares.com, and that provides lots of information regarding forestry management as well as some climate conditions for the region. The Southern Regional Climate Center and the Southeast Regional Climate Center cover the entire southern portion of the country. With the Southern Regional Climate Center, it has Mississippi, Louisiana, Arkansas, Texas, and the states to the western part of the southern side. And then the Southeastern Regional Climate Center has Alabama, Georgia, Florida, and the Carolinas, and the states to the eastern side. The Climate and Agricultural in the Southeast blog, along with AgroClimate, are blogs and websites specifically devoted to forestry and agricultural industries. And so they keep users up to date on current climate conditions that would specifically impact those industries. And so it's nice to have those types of interpretations of the climate for your management decisions. And then finally, you can go to climate.gov to get the NOAA outlooks for monthly and seasonal precipitation and rainfall conditions. And with that, that's the end of my talk. If you have any questions, my email address is listed there, and you can always shoot me an email if you have any follow-up questions. Thank you.